Hey folks, welcome to JavaScript Fundamentals 201. This is the first lesson of this course, and this course follows the first course, which was called JavaScript Fundamentals. Now, it's not a requirement that you watch those videos, but you do need to know the information that is covered within the JavaScript Fundamentals. So if you haven't watched those videos, look at the table of contents, make sure that you know those topics, because I'm going to assume that you have at least a basic understanding of JavaScript and how we use it within the browser. Of course, the whole purpose of this JavaScript Fundamentals series is to get you familiar with the language and how we use it with the browser, but some of the topics that we covered in the first course I'm not going to revisit. We might have a brief little refresher, but that's going to be it. So today we are going to talk about math, and I know that that's not a very exciting thing to start this course with, but math is an important part of a programmer's life because we use it almost on a daily basis. It might not be something overly complicated or advanced, but we typically do basic arithmetic on a daily basis. And in the first course, we talked about the four basic arithmetic operators, addition, subtraction, multiplication, and division. And really, we can use those basic operators to do just about anything that we want. But naturally, it's going to require a little bit of extra code in order for us to do that. So let's look at an example, and I'm going to do so by using a website called JSFiddle. This is a very nice website that you can use as a tool to basically test any ideas or any code that you have. In the case of this particular example, I'm just going to put in JavaScript, but you can also put in HTML and CSS, and then you can run it all and see the actual result within the browser. So I'm going to use JSFiddle throughout this course. I'm not going to exclusively. I'm still going to use Web Matrix, but for little simple demonstrations, especially dealing with HTML and CSS and JavaScript, this would be a nice tool because then you can see all of the pieces together and then see the result all there on one screen, and that's just better for you. So if you ever need to test anything, if you ever want to mock up something and make something work, you can go to JSFiddle. It's absolutely free, and as far as I know, it's going to remain free. So that's JSFiddle. Okay, so I have some code that basically performs exponential math. It's 2 to the third power, or 2 cubed. And you can see in this first line of code, 2 times 2 times 2, and that's being assigned to a variable called value. And then we alert that value within the alert message box. So we should see 8 whenever we see this. And there we go, 8. So this is, exponential math. This is very easy to do, but what if we have something like 13 to the 23rd power? Well, yeah, we could write that out if we wanted to, but we are human. We are going to make a mistake, and we could make a mistake as we are calculating 13 to the 23rd power by physically typing that out. And there might be times when we don't know the actual values that we want to calculate, but we know that we want to perform exponential calculations. So this isn't really the best approach. And a better approach would be to use a function. And I've actually already written one, so I'm pasting that in. And this is called to the power. It accepts a number and an exponent. So if we were going to calculate 2 cubed, we would call to the power, pass in 2, and then 3. The first line of to the power assigns the num parameter to a variable called value. In the case of 2 cubed, this would be the equivalent of 2. In 2 times 2 times 2. So this is the first piece of performing our exponential calculation. And then we have a loop. And the reason why we have a loop is because a loop is exactly like an exponent. Because what is an exponent? You are multiplying a number by itself for a certain amount of times. Well, a loop executes one or more statements for a certain amount of times. So it makes sense to use a loop here. We have a counter called I, and we are initializing it with a value of 1. The reason why we're starting with 1 instead of 0 is because we already have the first piece done by creating this value variable and initializing it with the value of num. And then we loop for as long as I is less than the exponent, and then we increment our counter. So we are going to execute this loop for as many times as needed by the exponent. And then the only statement that we have is value equals value times num. So this is going to keep a running total of multiplying the value by the number, and then we return the value after the loop exits. So let's create another variable. We'll call this var value equals to the power 2, 3, and then let's alert value, and then we should get 8. So I'll hit run, and whenever this runs, we get 8. So now we have a function that can perform exponential calculations. So let's do the 13 to the 23rd power. Let's run that, and we will see some huge number. And there we go. So I've shown you this code not because this is the best way to perform exponential math, because it's not. But I want you to see that we can solve problems by writing code. No matter what our need is, we can typically write code to solve that need or to fill that need. Because after all, that's why we write code to begin with. We have some problem that we want to either completely solve or to make managing that problem a little easier. That's why we write software. Naturally, we aren't going to be able to write code to fit every need that we have because there are some limitations that we just can't get around. For example, the browser doesn't give us access to the file system on the device that the browser is running on. That would be a security risk. So we can't write code to access the file system because that ability is not given to us. But in the case of our code here, we needed to perform exponential math. And since we didn't know a way to do that, we wrote our own code. So we kind of solved our own problem. But JavaScript gives us the ability to perform exponential math. In fact, it gives us the ability to perform multiple advanced mathematical calculations by using an object called math. It begins with a capital M, and it's just simply math. And then there are methods that we can use to perform some mathematical calculations. For example, to perform exponential math, there's a method called pow. And we simply pass in the number and the exponent that we want to use for our calculation. We call the method, assign it to a value, and then let's alert that value. So math.pow, we are passing in 2 with an exponent of 3, so this is 2 cubed, and we should get the value of 8 whenever we alert this. And there we go, the value of 8. So if we wanted to do 13 to the 23rd, just simply change the values, click run, and there you go. A related method to pow is square root. So if you wanted to calculate the square of something, first you would do pow, and then simply use 2 as the second parameter because that is squaring whatever number is specified. But if you want to calculate the square root, that is sqrt. So let's change this to something that gives us a nice even number. Square root of 9 is 3, so whenever we run this within the browser, we will see an alert box that says 3. So pow for exponents, or you can think of pow to the power of, and then square root is kind of self-explanatory. Well, let's say that we have a fractional number, so let's do 9.13, and we want to round this number to the nearest integer. Well, we actually have 3 rounding methods. The first is called round, and this rounds based upon what we would think as far as rounding is concerned. It looks at the tens place. If it is 5 or more, then it rounds up to the nearest integer, which is 10. If it's 4 or less, then it's going to round down to the nearest integer, so it would round to 9. So in the case of the code that we have here, this is going to round 9.13 to 9. So when we run this, we will see 9 within the window. There we go. And let's change this to 9.53. Now we will see the value of 10 because it rounded up to the nearest integer. Now, the other 2 methods round numbers, but they do so a little bit differently. The first is called ceil, as in ceiling, and it rounds up to the nearest integer, regardless of what is in the tens place. So if you have a fractional number and you use the ceil method, it's going to round up to the nearest integer. So if we do 9.03, this is going to round up to 10. See, There we go. And if we want to round down to the nearest integer, regardless of what is in the tens place, we use the floor method. So let's change this to 9.99, and this is going to round down to 9, because that's what the floor method does. So now let's say that we have a list of numbers and we want to find which one of those is the highest. To do that, we use a method called max. And it accepts as many numbers as we want to give it. So we could pass 2 if we wanted to, or we could pass 20. Now I'm not going to pass 20 because that's just kind of pointless. But let's pass 20, 6, 10, 12, 75, and 3. The max method is going to look at all of these values and return 75 because it is the highest. So let's run that, and we will see 75 within the method. The exact opposite is called the min method, and it will return the smallest number. In this case, it's going to return 3. The max and min methods also work with fractional numbers. So if we have 3.01 and 3.02, it's going to return 3.01 because that is the lowest number. So max or min to get the highest or the lowest number within a list of numbers. The next method we'll look at is the ABS method. It stands for absolute value. And if you're not familiar with absolute value, it is the distance from 0 of whatever number it is. So in the case of 7, the absolute value of 7 is 7 because its distance from 0 is 7. If you want to find the absolute value of -7, it too is 7 because its distance from 0 is 7. So no matter if you feed a positive or a negative value to the ABS method, you are going to get a positive value back because that's just how absolute value is. So if we run this, we will see the value of 7. There we go. The final two methods we will look at are geometric methods, the cosine and the sine methods. Let's look at sine first. It is not S-I-N-E. I have no idea why they saw fit to leave off the E, but it is S-I-N. So it looks like sin, but it's actually sine. And then you feed it whatever angle that you want to find the sine of. This is going to give us that number. And then if we want to find the cosine of that angle, it is simply cos, C-O-S. And that will give us a different number. So those are the notable methods. You can also find tangents. You can, we need to look at random because there will be times you want a random number. The random method is, guess what? Random. And it returns a random fractional number from 0 to 1. Now that doesn't seem very useful, but you can modify that in order to actually get a whole number. So let's first look at the values from just plain random. So let's run this. We will see some random fractional number, and then let's run it again, and we could keep doing this over and over again, but we can actually write some extra code to make this a random integer. So the first thing let's do is make this an integer. We will do floor, and this will give us the ability to have a random number beginning at 0. So if we just did this, it wouldn't be very random because we would actually just get 0. But if we multiply that by whatever number that we want as a limit, let's say that we wanted to have a random number between 0 and 10, well, we could just multiply that by 11, and that's going to give us a random number between 0 and 10. So if we run this, we get 7. If we run it again, we get 2. If we run it again, 8. And then if we wanted to, say, have between 0 and 100, then we would have to multiply that by 101. So this will give us a different range of random numbers. So that is another important method that I'm ashamed to have forgotten about, but those, I promise, are primarily the main methods that you might use. Some of them you might never use, but at least you know that they are there. Now the math object also gives us some constant values, some values that we might want to use in other mathematical calculations. For example, pi. I know 3.14. Beyond that, I really don't care what it is, but we might want some extreme accuracy. Well, that isn't very extreme, is it? But the math.pi is a constant that we can use in other calculations if we wanted to. So math.pi, there is the square root of 2, so it's square root of 2. This is going to give us a constant of the square root of 2. So if we run this, then we will see the 1.4, which is the square root of 2. We can also get the square root of 1/2, and that is 1 underscore 2. So it's square root 1 underscore 2. Run that, and we will see that value as well. So these constants are properties. They are not methods. If we try to execute them, we are going to get an error because those methods don't exist. So they can be helpful if you do need those values, but whether or not you need them is up to you and your own projects. And with that, we will end today's lesson. I know that it wasn't very exciting, but the math object is a very helpful utility to know about, because if you do need any of these methods or constants, there it is. You don't have to write the code to do it because it's there provided for you. In the next lesson, we are going to talk about dates, which isn't much more exciting, but once again, it's good to know that the JavaScript language gives you the ability to use dates. So we will look at the date object and look at how we can work with dates in the next lesson. So have a good one. I'll see you next time.